Hello and welcome to CTS Talks. I'm Nick Gibson and today we're talking about the industrial metaverse. What is it and how can it benefit industry? I'm joined by Kiran Kumar, ICT Research Director at Frost & Sullivan, who'll explore some of the key elements surrounding the industrial metaverse. Kiran, welcome.
Hi, Nick.
The industrial metaverse, it's big and is going to get bigger. So what are the benefits of the metaverse to business and industry?
Before I, straight away jump on to the benefits, of the industrial metaverse in particular, let me just quickly detail out what is metaverse, right? So basically, again, I don't want to run into definitions here. The central idea behind the metaverse is very simple. A virtual world in which an unlimited number of people can interact with each other in real time, just like we're doing now. It's a place where people can talk, shop, play, and work, and go beyond some of the limitations of the physical reality that we have today. And industrial metaverse is obviously a subset of this concept. Now, at the very outset, industrial metaverse refers to a world that is always on, where digital twins, that is, when the virtual replicas of real machines, factories, grids, and even cities are mirrored in the virtual space. Now, one may wonder, why is it so important to even create a virtual world, virtual space, or a digital twin? Like you asked, right? So what really are the key benefits? So firstly, in a virtual environment, problems can be identified, analyzed, and fixed much quicker, or at times even before they arise. Secondly, it allows us and the industrial players to break the barriers of distance and work from, basically break the barriers of distance and enable work from remote locations seamlessly, as if everyone were in the same room. Thirdly, on a broader level, it serves as a medium to test new ideas easily and quickly, which is where innovation takes off, if you ask me. So it could be as simple as testing a new design of a physical object or a product vis-a-vis digitally visualizing the entire manufacturing facility or plant operations, make necessary changes, and enhance digitally before even investing in a physical facility or say a facility. So the opportunities of what we call the industrial metaverse are still rather unexplored, but they are definitely emerging. And that aside, I already mentioned about remote working, which is going to cut down a lot of unproductive travel time. Secondly, it can also help factory owners overcome skill shortages, be it in terms of field engineers or maintenance staff or support workers. It will also allow for immersive training. So the experience is going to be as close as to the real thing as possible. Something akin to using high-end flight simulations for pilot training, especially in the process industries. Talk about petrochemical, pharma industry. It will enable trainees to realize the consequence of potential or potentially catastrophic user errors. For example, when a stressed worker pushes the wrong button by mistake, what happens? So those things can be learned very quickly, through the virtual space. And lastly, customer experience. So from virtual test runs to moving customer support using holograms to demonstrate how to fix something, Metaverse will enable businesses to offer experiences that they couldn't offer even in the real world. So those are some of the key benefits that Metaverse offers for industrial players.
So I understand that automotive companies are starting to use Metaverse technologies in terms of digital twins to recreate entire production lines with all the robotics involved, to see how that works. And I think BMW are going to roll this out across 31 factories. So basically, I guess they can see what's happening real time. Have you come across examples of this in the automotive industry?
Automotive, definitely yes. You mentioned about BMW, which kind of created a virtual twin of its Regensburg production plant. So global teams now use the virtual or the digital twin to collaborate in real-time 3D. So BMW claims that the method is revolutionizing its planning processes. We also had Hyundai. Uh, uh, Hyundai kind of conceptualized its fuel cell truck, hydrogen fuel cell truck. I think it's called as Hyundai's Neptune. So this was entirely conceptualized using a virtual development process wherein Hyundai motor designers across countries were enabled by business communication tools to participate in virtual meeting rooms. So enabled through their VR headsets, the designers were able to interact with a 3D model of a truck and were able to finalize and change the design, be it suggesting a suitable aesthetic for the headlamp, to changing the material being used, to the dashboard design, all through the swish of a finger. So that is one of the examples that we've come across. BMW again, Hero Group in India kind of visualized the entire factory before setting it up in a location called Vadodara. This was a few years back. So it was one of the first automotive companies to kind of entirely visualize a factory through a digital twin approach. So there are several such examples.
You can build something before you actually build it.
Exactly, that's right. Yeah, you can literally kind of like I said earlier, you can definitely check for yourself what is working, what doesn't work, where can enhancements happen. Even to the extent that where do we have a lot of factory staff crowding amongst themselves, how can we kind of change the design even to the extent of floor plan in an automotive factory. So all of that can happen through digital twins and metaverse in future.
I was talking to somebody the other day in the pharmaceutical industry who was saying that they're starting to use metaverse technologies and digital twins for drug trials, for the development of new drugs, whereby they can replicate a drug trial, but without having to always use human beings. They seem to get an awful lot of benefit and speed to market from that. Have you come across the use of digital twins in the pharmaceutical industry?
I would say that the examples that we're seeing currently in the pharmaceutical industry are more exploratory in nature. I have not come across any commercialized metaverse use case in the pharmaceutical industry. Something which would come close to that is not exactly pharmaceutical, but AB InBev. They've kind of created a comprehensive digital model of its breweries and supply chain. Simulations are currently underway with digital humans to test how real human bodies would respond ergonomically and efficiency-wise to newer workflows. So again, there are more demonstrations for sure to come as we move forward.
So there's an awful lot of elements, it turns out, to metaverse and the industrial metaverse in particular. So what are the major technologies and solutions used to power and enable the industrial metaverse?
Sure. A number of technologies would be required to access, interact, develop, and to realize the vision of metaverse today. So, at Frost & Sullivan, we kind of look at three important layers, what we call as the key constructs of the metaverse. So we look at 3 layers, which is hardware, software, and services. So talking about the hardware constructs, basically, access points. So predominantly, we believe that AR/VR devices would serve as a primary gateway to access the metaverse or spatial web, although form factors may eventually range from smart glasses to haptic wearables, IoT devices, sensors, robots, autonomous vehicles, and beyond. And secondly, the compute infrastructure. So the metaverse can't thrive without the physical universe. The infrastructure to support a concept as bold as metaverse cannot be limited to a small number of physical locations. It needs to be extensive, especially considering that it needs to feed into local requirements and exhibit ultra low latency. So with respect to data centers, as we understand, metaverse will require a massive platform new capacity requirements will arise as it creates completely another global ecosystem of applications and users. And applications supporting a metaverse would likely have similar requirements as today's modern platforms. So we're talking about dense compute, massive storage, varying latencies. Some applications will require proximity to dense population centers, while others may reside in low-cost rural facilities. And since we are on the topic of infrastructure, services will also play a crucial role in enabling the metaverse ecosystem. So it'll, the partners who are involved in the metaverse ecosystem today, they'll have to definitely scale to meet fairly universal requirements. I already mentioned about proximity to sort of minimize latency and ensure the content and other assets can be stored at optimal points in the network fabric. Similarly, taking care of the power requirement because it responsibly serves the needs of the servers, storage, networking, and cooling that are crucial elements of any data center today. Connectivity services that ensures metaverse experiences are delivered smoothly, rapidly, and across any distance to reach virtual communities worldwide. And lastly, sustainability. It's a key focus area because it's very important to minimize the environmental impact of new construction, new power sources, and new markets not historically considered to be data center hubs. And lastly, the software constraint. Obviously, artificial intelligence, machine learning will play a foundational role in handling the computation aspects. It will kind of enable machines and devices to understand the non-digital world, for example, via computer vision or through natural language processing. It will also drive contextual, personalized experiences. And lastly, as data sources and types are going to increase constantly, it will make privacy a critical consideration. And that is where many consider distributed ledger technologies such as blockchain will play a foundational role, because blockchain's authentication capabilities can enable open ecosystems without restricting users, as many platform-based applications do today. So all these technologies will have to come together in order to realize the vision of metaverse.
So it strikes me, again, in talking to a number of people, that they're, apart from anything that is sort of bespoke to each individual use of the metaverse in industry, the two key elements, as I understand it, one is there enough power physically available to be able to power all the processes involved? And the other key element, it appears to me, is interconnectivity, because there'd be so many different things joining up to make something work for an organization in a production line, for example. Interconnectivity and power available seem to me to be two of the core foundations, which at the moment, it may not all be there yet.
Yeah, I mean, again, when you talk about power, are you referring to the compute power or the energy?
Well, there's two things. Obviously, with quantum computing coming on, there will eventually be enough with these yottabyte files and all the rest of it. There will be enough sort of bandwidth power there. But in terms of energy, I think someone at Intel was talking about, in order for the metaverse to reach its full potential, there'll need to be 1,000 times more power available.
Definitely. NFTs or cryptocurrencies are going to be an integral part of the metaverse equation. And just to cite one instance, since we are on this topic of energy, each Bitcoin transaction today requires roughly 2,000 plus kilowatt hour of energy, greater than the per capita consumption of many countries. And the majority of this energy consumption happens during the mining process. So once coins have been issued, the energy required to validate transactions is minimal. And similarly with NFTs, according to industry analysis, a single NFT from minting to transactions to ownership, its carbon footprint averaged a whopping 200 plus kgs, roughly about 210, 211 kgs of carbon dioxide. So putting this into perspective, this is roughly equivalent to carbon emissions of, say, driving 1,000 kilometers on petrol, or flying an airplane for 2 hours, or say, boiling a kettle at our home 5,000 times, roughly. So, but having said that, what we are also seeing on the other hand is that there is an increased adoption towards renewable sources of energy. So the proportion of renewable sources in total energy consumption, especially since I mentioned about crypto mining, is now roughly about 35 to 40%, according to one of the Cambridge studies. So and there are newer innovations, technology-based innovations, which kind of are looking to move transactions off-chain, thereby minimizing energy needs. So there are companies like Startware who are kind of currently involved in this process. So they believe that it will act as an alternative to the fundamental proof of work engineering contract on which the blockchain is built. So I believe definitely yes. There's going to be a lot of power consumption when we talk about metaverse eventually, and again even the compute power. So I earlier mentioned about compute power, right? So again, the Meta, for instance, their new supercomputer. I think they are building, in fact, one of the world's fastest supercomputer with the deployment of NVIDIA's DGX A100 systems, and they are using roughly 16,000 A100 GPUs to train these models for a variety of purposes, including metaverse. And that's again going to consume a lot of power. So every aspect, and we spoke about data center earlier. So there is definitely a lot of power consumption that is going to be involved in metaverse. And again, from where we are seeing this today, the entire metaverse in itself is in its infancy. There's definitely a lot more development that needs to happen, even in terms of technological developments, be it in terms of business challenges. There are definitely a lot more developments that need to happen to fructify the vision of metaverse.
Interconnectivity again is or has been flagged up as being a key element, very much in some respects, very much like the early days of moving from analog to digital telecoms, and the need there to integrate all kinds of different systems and different formats. Is there an architecture there, a standard architecture available to enable the use of the metaverse in industry, or is it still a matter of everyone's having to do something bespoke in order to join up lots of different things that they're using?
We're talking about transmitting rich contextual media experiences, which are going to receive or require extremely fast network connectivity. And all of this will depend on high bandwidth networks and more distributed locations for computing, which will make 5G connectivity and edge computing core enablers. And it's about having content distribution network and connectivity options available in conjunction with edge data centers so that you can improve the overall experience with the end user. So for infrastructure and data centers, the content distribution networks and connectivity options and ecosystem will play a critical role, as data needs to be served to the end user with low latency connections. So I believe that with 5G in place, and we've already seen some real-time demonstrations as we speak in various places, like especially in South Korea, for instance, in Spain. So I believe with 5G coming in and with more installations on edge data centers and more installment of content distribution networks, I'm sure the connectivity issue will be fairly addressed within the metaverse space.
What are the main challenges involved? Are they practical, technological? Are they financial? Or maybe there are cultural sort of buy-in issues involved because it's so new? What are the main challenges?
It's almost all of that because, first and foremost, let's cover technological because that's going to be the basic premise there. So we at Frost & Sullivan believe that interoperability is going to be the defining property of the metaverse, because the benefits of having an interoperable metaverse are numerous. For one, it would allow users to move freely between different virtual worlds without having to start from scratch in each one. This would be especially useful for businesses which could set up their presence in multiple virtual worlds and reach a larger audience. So the metaverse or the virtual worlds need to unify systems and platforms which sort of constitute an engineering problem, and as well unify economies in terms of incentives and benefits tied to the physical world, which also reflects a social and business problem. Secondly, as I had mentioned earlier, the technology components that constitute a metaverse today can fulfill only a fraction of the intended vision. The mainstream adoption of the metaverse will entirely depend on technology advancements to build experiences that can seamlessly fuse the physical and the virtual environments. So I'm talking about developments in spatial audio, creating high fidelity digital twin representations of the physical space, enabling new multi-user collaborations and interactions at scale in a virtual space, enabling decentralized and scalable payment systems, and providing latency-resistant networks. These are few examples of technology-based applications that require refinement. So several technological breakthroughs are required to offer a realistic metaverse experience to end users. Secondly, IP protection. That's going to pose a new challenge. Ownership of art and properties in the real world is a different domain against what we're seeing in the virtual world. We're already seeing that NFTs are raising legal concerns over intellectual property ownership and rights. Due diligence in terms of ensuring the IP is protected is something that companies have to look into. In terms of business challenge, now brands need to consider how to advertise new innovative products to a consumer base that is already familiar with the services efficiently across numerous contact points. And on top of it, you are asked about financial. So again, for brands, for companies, there's going to be significant expenditure in terms of setting up the infrastructure in its entirety, in terms of investing in skilled people to support, and then training those staff and the wider employee base. But if the company's clients are searching for a digital experience, and if the brand or the enterprise can meet those expectations, then the return on investment makes the expenses look practically rational. These are some of the issues in terms of technological and business challenges. Now, in terms of a very important challenge that remains, two important challenges, I would say. One is standardization. We spoke about interoperability earlier. So navigating between different 3D worlds will be fundamental to the success of a metaverse. Secondly, in terms of access points, so there are questions being asked today. Is the metaverse accessible to anyone via any browser, or is it tied to just one application, mobile application? And how about using other platforms, say gaming consoles, for example? Can you access it via those? So the focus for metaverse platform designers today should be to ensure immersive experiences are compelling across a range of devices, allowing consumers to choose their preferred gateway into the virtual world. And standardization could also be in terms of, it could also evolve in terms of interface mechanics, for instance. So when we use our smartphones today, we normally swipe or double tap or drag and scroll, our fingers for zooming in. Basically, these are standard ways of engaging with 2D content today. The metaverse will similarly give rise to new ways of engaging with 3D content. I don't know, it could be just waving our hand or wrist rotation or opening our palm or something else. So the interactions will need to be standardized across virtual worlds. And lastly, I believe privacy is going to be a huge concern, because virtual worlds will gather different types of user data, including personal information, be it age, gender, name, user behavior, could be our choices, habits, and also take metadata from personal communication. So engaging in a virtual environment might just expose users like us to continuous monitoring and hacking. Further, these virtual worlds can also potentially create a gray area for digital abuse. It could be hate speech, it could be in the form of violence against women. So digital abuse, in fact, is noted to have material and psychological impacts on end users. So we need technological solutions to restrict digital abuse and moderate user experiences in the virtual worlds. So be it federal bodies or enterprises who are looking to dip their feet in metaverse, need to ensure they develop compliance policies and frameworks that structurally define behaviors for users in the digital world. So these are some of the challenges top of my mind that we see in the metaverse.
So, Kiran, I do thank you for your time and your expertise and for your insight. Thank you very much indeed.
Thank you, Nick. Pleasure is mine. You have a great day ahead. Thank you.